All right. So, revision. Okay. What are we doing? We're going to start with absolute value equations. So let's remember how to solve absolute value equations. Solving absolute values. Absolute value equations. Okay. So the idea with absolute value is that you've got two straight lines, and then the idea of it is you're actually finding the distance. I never spoke about that before. But you're actually saying what's the distance of 5, or what is the magnitude of 5? Well, the magnitude of 5 is 5. And then what is the distance of negative 5? Technically, the distance of negative 5 is still 5. But the absolute value just keeps things positive, right? And that's how I would have said it at the beginning. So absolute value of both positive 5 and negative 5 is 5. So what that means when we're trying to solve for something is that technically this expression here can have two answers, right? It can have absolute value of 2, which would give you 2, or it could be absolute value of negative 2, which also gives you 2, right? So what we would have learned is that if you've got an absolute value equation, to solve for it, you always have it in two forms. Your first form is x plus 5 must equal to 2. So x plus 5 equals 2. And your second version is that x plus 5 can also be negative 2, because you just saw if I absolute valued it, it still gives me a positive 2. Any questions at this stage? So when you see an absolute value, the first thing you do is keep one side positive, the other side positive. Then second one side positive, I did, the other side negative. Now it doesn't matter if you choose your left side or the right side, it's just one side's negative. And then of course you solve. 2 take away 5, negative 3, x equals negative 2 take away 5, negative 7. And then it's always good to just sub it back in and check. Minus 7 plus 5 is minus 2. Absolute value of negative 2 is positive 2, and then minus 3 plus 5. Okay. Any questions at this stage? So, Alessandro, was this the question you were having problems with?
Yes, but also where there's an x on both sides.
Yeah, I'm going to get to that now. But I'm saying, like, that so far, so good.
Yeah.
Okay. Then, as long as you guys don't change your method, it doesn't change from this. You see how Alessandro just said, oh, I don't know what to do when there's x's on both sides or whatever? He's changing the method. That is not a way that I personally teach. So what I like to do is teach one way, like this now, and that can be applied 1,000 different ways. It shouldn't really change. Cool? So now I'm going to go through all the different versions of what you could get in an exam, and we'll see when it does change, if it does change. Hopefully it doesn't. So as long as you know with an absolute value, the other side's positive and then negative. If it was 2 absolute values, then that technically there would be 4 different options, but we'll look into it all. So let's do that basic. Just, Alessandro, you understand what I mean by don't change your method? You've heard me say that for a long time. You've been with me for a very long time.
Yeah.
So you know me with that. Like, don't change. It's when you decide to change that you ask the questions you're asking me now, like, oh, what happens if there's an x, or what happens if there's 2, or whatever it is. So let's just keep that in mind always. Remember, the Sam says don't ever change. So that's the option 1, or method, or question style 1. Other than this, so the other one could be if you had 2 absolute values. Technically, there's four solutions this time. Why would there be 4 solutions? Because each absolute value would need a positive and a negative. So technically, it looks like this. X plus 5 equals 3x take away 2, right? Positive, positive. The next one would be positive, negative on the right-hand side. The next one would be, so now you just did positive, negative, positive, positive. Then you've got to do negative positive and negative negative. I'll pause there. Do you guys understand this line fully? Do you agree that that's what you need to do? Do you understand that that's what you need to do? Because here, up here, we did one absolute value, we did positive and a negative. Therefore, you've got two absolute values. Therefore, you're going to go positive, 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 negative, then negative, positive, and then negative, negative. Exactly like if I had told you tail, 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 heads, heads, tails, heads, heads. Right? You would have done the exact same thing. There's 4 options. Lissandro, sounds good so far?
Yes.
Technically, like I keep saying, 4 solutions, but what should happen if you've done it right, you'll only get 2 solutions because these 2 would match and these 2 would match, technically. But let's see. X, take away 3x is negative 2x, minus 2 minus 5 is minus 7, x equals 7 over 2. Expand this, minus 3x. Please stop me, you guys, if there's any questions. 4x, 2 take away 5, and all I'm doing now is just solving, so you don't even need to look at my work too much. Minus x, minus is minus 4x, that would have been minus 5, minus 2 plus 5 is 3. I'm just going to go a little bit faster. Negative 3 over 4, see, they matched. And then this one, minus x, minus 3, so you're going to plus it over, it's going to become 2x. That's minus 5, that's plus 2, 2 plus 5 is 7, therefore x equals 7 over 2. All right, you guys, any questions? It's just going to be easy to highlight. No questions. What must you do? What did I say here to do? Just after you're done, Lissandro. When you're done, what is a good thing for you to always do when you've solved something?
Rewrite your values.
Say that again.
Rewrite your values.
Rewrite. No need. That's perfect. Otherwise, you don't need to rewrite them technically. How do you know if they're exactly right? Shouldn't you just sub it back in and just test it real quick in case you've done a calculation error by mistake, you've done something wrong, you added, subtracted, whatever. Test it in. So if you wanted to, please you guys, go and test both of these in. Use your abs button, absolute value, just under your shift, and make sure that both sides equate. And if for some reason one of them don't, you cross it out. If you're 100% sure you haven't done anything wrong, cross it out, and there's no solution for that one. But I don't see why both of them won't work. So someone just confirm. So, yep, 7 over 2, did it work?
Yeah, it worked.
And then negative 3 over 4?
Yeah, it worked.
Worked as well. Josh, thank you. Done. See, there you go. So, that's it. Lissandro, did I do anything differently than I did with the first one? No. You might say yes, because you're like, oh, well, now you've got 4 solutions. The only reason why I've got 4 is because each absolute value would have a positive and a negative.
Yeah.
But realistically, I mean, that's it. All right. This one here, you usually don't need to check. Just so if you want to learn a quicker method now, you don't need to check. It's good to get used to it, but you don't need to, because technically the left-hand side is always going to be what? Positive. The right-hand side is always also going to be what?
Positive.
Positive. So you shouldn't have a problem here. The one you will have a problem is this one. Absolute value of x plus 5 equals 3x take away 2. What's the problem here? Left-hand side's always positive. Right-hand side?
Negative.
Not always positive. You can't say that. It's not always positive. You can't say it is, because if x was 1, 3 times 1 is 3, 3 take away 2 is 1. It might work. But if x was negative 1, or x was 0, 0 take away 2 is negative 2. That's great. This guy would never be negative. So x equals 0 cannot be a solution, even if you've solved for it. Sounds good?
Yeah.
So me, if I was me, when I look at this, I already alarm bells ring to me and go, gotta definitely double check. These ones, I'm not so worried about. Unless I've done a calculation error, fine, you should learn to test, but I'm not worried about it as much as I am with this. This one, super worried. Same as if you guys remember when we did logs. Okay, sweet, like here, look, log x plus 1, you solved it, you know, exponential both sides, that becomes E5, and then you subtract it, whatever, great. Happy days, right? No problems, whatever. Even if you guys don't get that yet, it's okay, but I'm sure we do. It's fine. Now, the problem is not that you've solved something, is if this was actually -1, just assume it was -1 for a second. If you sub it in, -1 plus 1 is 0. And if you guys remember your log graphs, or if you just remember, you can't log 0. So even though you've solved x equals -1, that's great. But you can't, when you sub it back in, it just doesn't work. So the answer is no solution. Like mathematically you solved it, great, good work. No one's going to take that away from you. It's just that the answer is no solution because it doesn't work. And that's what you've got to keep an eye out when you're doing these kind of questions as well. You guys all with me? We understand? Any questions at this stage? So I do what I do usually. There's my two versions. X plus 5 equals 3x take away 2. X plus 5 equals -3x take away 2. Solve, bring this over. X equals 7 over 2. There's one answer. Do this. Bring it over. 4x. 2 take away 5 is -3. Now, you can't cross out anything yet. You can't say, oh, no, this doesn't work, this doesn't work. You don't know. Okay, so you got to sub it back in. So I'm going to test x equals 7 over 2. 7 over 2, 7 plus 5 is 8.5 on the left-hand side, which is still absolute value, so it's positive. On the right-hand side, 3 times 7 over 2 minus 2 is 8.5, positive. Happy day, this one's not wrong, so this one's right. This one, -0.75 plus 5 is 4.25 on the left side, which is positive still, great, equals the right-hand side, 3 times -0.75, take away 2 is -4.25. There is no absolute value. This will never equal to this. So, not an answer. Lissandra, any questions for me? That's the only answer.
Oh, that's it.
That answers everything?
Mm-hmm.
Anybody else? That's like,
Hey, Sam.
well, yeah, tell me.
For the previous question
For
where we
previous-
said -3 over 4 does equal,
Yeah.
when I done it in my calculator, I got that the x plus 5 was
Yep.
positive, but the 3x minus 2 was negative. Oh, but
But it's
my
absolute
bad, it's in
value.
absolute values. I didn't see that, my bad.
Good job, good question. See, look, they're the same answers. I did that on purpose, 7 over 2 and -3/4. But what happens when you sub it into the right-hand side? You get negative, but if for the previous question, what did you have? You had an absolute value here. Then he made it the same. If you don't, it just doesn't work. So yeah, keep in mind, that's an absolute value that doesn't have it. So, and just so we're clear, sometimes not an answer, sometimes it is an answer. So don't just go, oh, all the ones that are negative is not an answer. It doesn't work like that. You just test both. Sometimes not an answer, not an answer. So what's the answer? If you get two x values that both don't work, what's your conclusion?
No solution.
No solution. Right? No solution. Good. Thank you. No solution. Like, it's great. You work, like, you can solve things. I mean, you're just solving, whatever. You're doing math. It doesn't mean that it physically can work. So just keep that in mind. Okay, good. Anybody else have any questions about these? That's it. So I hope that clears that up forever. You shouldn't have an issue if you know your basic first one. You know that I've said test them. And I guess regardless of what you get, you just do it normally and should be fine. Okay. There's no questions. We'll go to the next one, which is completing the square. Completing the square. Okay, another one that I do a bit differently to your teachers, because I do it in one line. So that's the only difference. Now we'll do the basics. After the basic, after the basic, we will do non-monic. So we'll do monic. Again, I'm running through absolutely every question you're going to get. You can't get any more than the ones I'm about to give you. So monic, non-monic, and then circles. That's it. There's only 3 versions. So monic questions. So questions like this: x squared plus 5x plus 6. Okay. Should be easy. So what's the idea of completing the square? Who can tell me by now what's the idea of completing the square? What does it mean? You're trying to find.
Trying to factorize.
You're trying to factorize it into?
Perfect square.
Yeah, that's why it's like the complete square. So it's got to be perfectly squared. So when you're trying to complete the square, you're factorizing, correct, so that it becomes a perfect square. That's it. So you technically know the answer. Technically, you know it's going to look like this squared. Technically, right? So if you know that, then the idea of it is, you know the expansion of this, don't you? The expansion of something like this is the first one squared, 2 times the inside, and then the last one squared. The problem is this is not going to be in this form, so there has to be some adjustments. Now, the constants are always going to go to the right-hand side. That's the way I teach it to you guys, and I'm sure the way your teachers would have done it anyways. So constants on right-hand side, always. So straight away, your next line is, let's get down here, and let's write monic. So wait, monic. Okay, so x squared plus 5x plus 6. Then you would write x squared plus 5x equals negative 6. Then because you know, if you have a perfect square, right, you know you need this. You know if you expanded this, it's going to become 2ab. So this number is already multiplied by 2. So what you've got to do to bring it back into this form, you've got to divide it by 2. That's why you're dividing by 2. So the rule is, then once you've got it, your constants on the right-hand side, halve it, is what you'll hear me always say, halve it, square it. Halve it, square it. So half of this is, there it is. Square it on the other side. There it is. All right, I'm going to pause there. You guys are going to tell me what you understand and what you don't, and what you want me to explain one more time. Any questions? No, we understand that one. So then minus 6 plus 25 on 4 should be a quarter. And then of course, you just bring it over and you're done. To complete the square is that's your factorized version, that's factorized. And if you had to solve, you would have square rooted here, obviously, because you're solving for x. So you would have had x plus 5 on 2 is equal to plus minus square root of a quarter, which is a half, and then you would have subtracted. So x equals negative 5 on 2 plus minus a half, and then work that out. Okay, seriously, any questions? Minus 2.5 minus half minus 3, which we know is the answer from just looking at that, factorizing that. So solve is this, factorize is this. You bring it back. No questions? Okay. We sure? 100%. Constants on right-hand side, halve it, square it. Okay. Where did you get 25 on 4 from? Halve it, half of this. What's half of 5? 5 on 2. Square it. What's 5 on 2 squared?
25 over
on
4.
That's it. That's the way it works. So half this, square this. Halve it, square it. Halve it, square it. Done. Let's try. And that's pretty much the same concept for all of them, but let's try non-monic now. Actually, we'll try circles, because circles are easier than the non-monics first. Circles. Ugh, can't even write circles. Circles. Okay, circles are in this form, right? X squared plus y squared equals r squared, or x squared plus y squared equals r squared. You know, perfect square, pretty much. Perfect squares. So you must complete the square if they're not. So for example, if I said sketch this, sketch x squared plus 4x plus y squared minus 2y minus 5 equals 0, you're going to look at that and be like, what? I don't know where this, I know it's a circle because it says x squared and y squared, but I don't know where the center is, I don't know what the radius is, so you've got to complete the square. To complete the square, we do exactly what I wrote up here. Wait, constants on right hand side, that's 1, 2, halve it, square it. You ready? Follow those rules. So x squared plus 4x plus y squared minus 2y equals 5. Constants on the right hand side, there it is. Now, bracket, bracket squared plus bracket, bracket squared. X plus half of 4, 2. And square it, 4. 2 squared, 4. Do it again. Y minus half of 2 is 1. Square it, plus 1. Always plus on the right hand side. But if you're doing it my way, we're always plussing. We're not never subtracting on the right hand side. And you're done. Now, ask me any questions you've got. Tiana, how do you feel about this one?
It's okay. It's not really.
It's
I need to
okay.
work more on it. It's not the best.
Yeah, no, because this is 100% in your exam. Circles.
Okay.
More than the mnemonic ones. So we'll do more. But what bit don't you, like, do you know the strategy now? So tell me the strategy. Step 1 is what?
You take the
Constants.
one constant to the other side,
And then
and then
step
you
2?
find the common per numeral together, and then just I say grouping it.
Yes, correct. Group them. Yeah, I see what you're saying. Yep.
Actually, yeah, I get the concept.
Yeah, and then
Okay.
halve it.
And then half it,
And
and then
what do you do on the right hand side to that half number? So now you've got
square
2.
it.
Square it. Halve it, square it.
Square
You just
it.
got to remember perfect squares. So the whole idea of completing the square is to have a perfect square.
Okay.
Good. Okay, Lissandra, what about you? You asked for it. What bit are you confused about? I can't hear you if you're talking. No, you're not there maybe. Something's happening. Eden, how do you feel about it? I think you're pretty good with these.
Yeah, I get it.
Yep. Vinesh, what about you?
Yeah, I'm good.
This is good? Yep.
Yeah.
Lissandra, can you hear me?
Yeah. Did you ask a question before?
Sorry?
Did you ask a question before?
I was just saying, like, how are you feeling with this now? Because you're the one who said completing the square.
It's just the half it and then square it part that I keep on forgetting. So yeah.
Otherwise, you know what you're doing. You're saying so it's just a halve it and square it bit.
Yeah.
Okay. So constants on the right hand side, and then bracket squared. Do you at least know to write bracket squared?
Yeah. Yeah.
Okay,
Yeah.
that's a super important thing to do, obviously, because you need that. And then you have, all right, let's do more. We'll do, I guess, 2 more of those. So it's question 2. X squared plus y squared minus 3y equals 7. Well, this one's already perfectly completed, right? There are no other x's, so this one's fine. So you just leave it. No need to do anything with it. X squared plus constants I already have on the right hand side, so that's super helpful. Plus open bracket y minus half it square it. Tiana, what do you think?
Yes, I'm comfortable with that, if that's what you're asking.
Yeah, that is right.
Okay.
You 100%? Like,
Yeah, I get that.
you would have done that?
Yeah.
All right, that looks good. Halve it, bracket squared. X's, you said group them, so there is no other x's to group, so yeah, you just leave that as it is. And then that, you halved it, 7 plus 9 over 4. Lysandra, all good?
Yes, sir.
28 plus 9, 37 over 4. So my center, can someone tell me what my center is?
Is it 0
think?
and negative 3? Oh, sorry.
Yeah, go Eden, you said negative?
3 over 2.
No.
Oh, okay.
What's
Okay.
the one thing you've learnt now from like equations and brackets? Equations and brackets. Equations. I'm just trying to make your life easier. I want to make all of your lives easier. Equations and brackets. So ready? Here's a bracket. And that's an equation now. What are your answers always? Isn't
Negative.
it? Yeah, isn't it the opposite of what you see?
Yeah.
If you see +5, it's meant to be -5. If you see -3, same thing. If you see a negative 3 over 2 in brackets, it's got to be a positive 3 over 2. You see a positive, it's got to be a negative, because you're actually doing this. You're actually solving for 0. That's what you're doing. That's why the answer to this is 0. So x equals 0. Then y minus 3 over 2 equals 0, which means y equals 3 over 2. Is that clear?
Yeah.
So you shouldn't ever, any time for the rest of your life, if you ever see equations, there it is, with brackets, you now know anytime you're about to use something from inside of it, it's got to be the opposite. Because technically what it's doing is it's moving to the right-hand side. Just keep that in mind, please. Cool.
Yes.
Okay. That's good. That's good. Now, I know I did say I'll do 2 more, but I think that pretty much covers that. What I'll do is do a monic, a non-monic, and then we'll see how we go with that. We'll probably do a non-monic circle. So now non-monics. These are, you got to be careful. I'm just going to write that. Because it depends if you're solving or you're factorizing. So it never mattered here. It doesn't matter up here. Here, it depends on if you're factorizing or if you're solving. Now, because it depends, I like to teach the way that will always work, which would be the factorizing way. Whereas the solving way only works if it is solving. And if it was factorizing, you won't get the right answer. Whereas the factorizing way, if it was factorizing, you'll get it right. And if it was solving, you'll get it right. So this way here that we're going to do, the factorizing will always work. The solving way won't always work. Let's have a look at the 2 questions. So 2x squared plus 5x, I don't know, minus 6. Wait, sorry, there, minus 6. If I was asked to solve this, I can just divide by 2. I can divide by 2 so that it is monic again. So that I don't have the 2 in front anymore. So pretty much you can't have 2's in front, ever. Just either way, right? So here you would divide by 2, and I'm sure that's probably what you guys have been doing. Something like that. Cool? Any questions? And then from there you would have completed the square now. So you would have got bracket squared equals, you would have brought your constants over. X plus half of this is 5 on 4. Then you would have squared this. There it is. And then you pretty much finish it off. Any questions at this stage? And then finish it off. Square root, plus minus, and then subtract 5 over 4. Do we understand that? Yes? All good? All right. The problem is, when you did divide by 2, if the question said factorize, you actually just got rid of the 2 that was meant to be in the front. So technically, if you said, oh, to factorize it, because this is what some kids say, oh, this is on the right-hand side, just bring it to the left-hand side. Which is correct if it was monic. The problem is, because it was non-monic at the beginning, you got rid of the 2, this answer is wrong. So let's have a look at, if the question said solve, like I said, do divide by 2, no problems, right? No problems. If it said factorize the exact same question, this would be the technique. You would have to factorize the 2 out. And I usually don't touch my constants, right? Because I know my constants can be on the other side. So don't bother factorizing 2 out from 6. Constants can go on the right hand side. That was step 1. So it should look like that. Compared to here, we divided by 2. Again, even if you hear you were dividing by 2, if it was equal to 6, when you divide by 2, you still got to do 6 over 2. So regardless, it becomes 3. But here, when you're factorizing, because you're only doing it to a side, you didn't have to touch it with the 6. I just brought the 6 to the right-hand side. Any questions about that? Then you complete the square. X plus 5 over 4 squared equals 6 plus. Now here's the tricky bit. When we say square it, it's 25 on 16. 25 on 16. You have to multiply that by the 2. So that's the tricky bit. So 25 on 16. So square it, but because there's a 2 in front, you got to also multiply by 2. And then the rest is going to be easy, but that a lot of students don't do. So do we understand that bit, Sandra? 25 on 8.
Yeah.
That's really important to remember. If it's non-monic, you have to just factorize. When you're saying halve it and square it, if there's a 2 in front, when you square this term, there it is, you've got to still multiply by 2, because think of the expansion of this. It would have a times by 2, right? You would multiply it by 2. So the right-hand side also has to have a times 2. And then if you want to know the answer, factorized, whatever this is, I'm just going to subtract it. Minus 73 on 8. So you can tell it's a little bit different to this one here. I guess you could do that. Now that I realize I have no problem with doing this. I just never taught it like this until I'm teaching you guys now. Look, if you guys did learn to just divide by 2 to make it monic, that's actually not a problem. It's just that if you were asked to factorize, right at the end, multiply everything by 2. If I multiply everything by 2, it'll look like this. And then bring it over, you're back to here. I guess that might make it a bit easier for some of you. Instead of thinking of factorizing. Multiply by 2 again. Everything. And then these two become the same. So it's the only one you got to watch out for. The fact that it's non-monic. The other ones, as long as you know the constants on right hand side, halve it and square it, keep the x's together, your y's together, really you shouldn't go wrong. But the non-monic ones, you just got to be careful. Now that I think I made it even easier, I might start teaching this from now on. I'll go, if you can solve, divide by 2 and at the end just multiply everything back by 2. So do you always multiply it by the number outside the brackets? Yeah. If you factorized, yes, absolutely, has to. Because you got to think of what's happening. What you're doing is factorizing. The opposite of factorizing is expanding. So if you expanded this, don't you have a times 2 still? So the right-hand side, you need to also multiply it by 2. You got to balance it. And that's what you're doing, technically. Alessandro, which one are you happy with? Solve or factorize?
The solve.
Both, maybe. I don't know. Solve?
Yeah.
At least now we created a trick for you.
Yeah. I can see how it works.
Yeah, that's simple. Just multiply back by 2. That's fair enough. All right, let's do it again. Let's do it again for a circle. And if you guys can get the circle, then I think we're good. Circle. Okay, 3x squared plus 4x plus 3y squared plus, I don't know, 6y equals 9. All right, Alessandro, what do you want to do? You can't have them 3s in front.
All right, divide by 3.
So we're going to divide by 3. So technically you now have this. Because circles are equations, so you're solving, you will not need to go back and multiply by 3. Do you understand that?
Yeah.
So just be careful. That's only for factorizing. So only for factorizing will you need to go back. Where are we? Let's write that. So when I send this back to you guys. Only for factorizing. Multiply back. Otherwise you don't ever need to. If you're solving, it's gone. Division by 3, it's not a problem. So then bracket squared plus bracket squared equals 3. X plus y plus. What goes in here, Alessandro?
Half of 4 and 3.
And?
Square it and put it on the other side.
So plus 4 on 3 is 2 over, 4 on 6 is 2 over 3. 2 over 3 is 4 over 9. And then same thing with this one. Half it is 1. 1 squared is 1. All good?
Yeah.
All right. Anyone have any questions for me? Because we're pretty much wrapping this topic up then again. 40 over 9. Center is negative 2/3, negative 1. Radius equals root 40 on 3. Any questions? All right. Happy days, happy days. Let's go. That's another one out of the way. I'll send this whole file to you guys just before we finish off, so you have that as well. Let's do first principles now. First principles. Okay, first principles. Okay, anyone remember the formula for first principles?
Is it
Limit as
h versus 0,
f of
x plus h,
minus
f of x.
over. It's got to be h. It's got to be h. It's got to be h. That's the whole point,
Squared, I think.
right? Because h is equal to 0 is a problem, and that's what we're trying to eliminate eventually. Good. Any questions? Let's do it. So f of x equals, let's do a basic one, x squared. We want to differentiate by first principles. So differentiate by first principles. To differentiate by first principles, it's literally this formula. F of x is already going to be given. H is going to be standard. You leave it as h. The only thing you don't have is f of x plus h. F of x plus h. So you replace your x for x plus h. Eden, Tiana, make sense?
Yep.
Yep.
Then we substitute, really. F dash x, so once you guys learn that that's going to be your first two things you got to get before f dash, then it's just limit h approaches 0, x squared plus 2xh plus h squared, right? F of x plus h minus f of x all over h. If you keep saying it the way I keep saying it to you guys, your f of x must cancel. It just must, because it doesn't have a h. If you have something that doesn't have a h, you won't be able to cancel your h. So see, you've got a h, you've got a h. So your next line, factorize your h out, cancel your h, and then pretty much, you don't have to do as many lines as I'm doing. Some of you might be doing it faster. And then sub in h equals 0, that's gone. You know the answer already by just doing differentiation. 2x, you just proved it. Josh, any questions for me at this stage? Or anyone else? Any questions? No, we're good. Okay. Let's do a harder one. No, it just looks messy, but it's fine for now. It's not really messy. It's not really messy, actually. As long as you know the formula, you're more just substituting in and then just doing algebra. But yeah, it might look messy because of the fact that you got to keep writing the limits and whatnot. But let's try another one. So differentiate by first principles. Y equals 3 minus x squared. So in other words, f of x equals 3 minus x squared, and of course f of x plus h. Well, there is no x here, so that's just 3. Don't be fooled by that. Minus, open bracket, x plus h squared. If you wanted to, Some kids would have expanded at this line. You can do that. There's no problems for that. There it is. And if you want to simplify it, there it is as well. That is f of x plus h, which is what I'm going to substitute into our formula. F dash of x equals limit h approaches 0 of f of x plus h. F of x plus h is this one. Minus f of x, which is this one, all over h. Now I want to show you something. If you guys wrote that, look what happens. 3, take away 3, gone. But what's minus x squared minus x squared? Minus 2x squared. It doesn't have a h. You've done something wrong. Right? I said this side must always cancel out. What I've done wrong is I didn't use brackets. Minus f of x. What happens this time is that becomes negative 3, so it still cancels out. That becomes positive x squared. Positive x squared and negative x squared cancels out. This right-hand side must always cancel out. All right, obviously you are this stage now, limit h approaches 0, minus 2 xh minus h squared on h. You can probably just see it, cancel, cancel, cancel. Sub in h equals 0. Your answer is just negative 2x, and you're done. Any questions? And then I will do a very different one that I usually don't teach until we're doing revision, because it's important to first understand the basics. But the next one I'm about to do, you guys are okay with that? The next one I'm about to do, I would like you to maybe put in your book, you know, that night before the exam book that we were talking about, Alessandro, highlight it, stick it on your wall, do whatever you've got to do, because this one here, it will be in one of your exams. I don't know which one it would be. It will come up. I can guarantee that. And the only way you'll be able to execute this if you know the trick I'm about to do. If you don't know the trick and you've never done it before, you probably won't get it out. So we're going to try to differentiate this by first principles. Differentiate by first principles again. Okay, here we go. What's the first thing I need before I start this? Before I start my differentiation? Eden, what's the first thing you would write? F of?
Middle formula.
Oh, not yet.
Oh.
You don't have what yet? F of?
Limit. F of x plus h.
You know the formula, right? The formula is this. So I mean, you could write it. That's great. You start to learn. I've got this. I've got this. I've got this. I've got this. What's the only thing you don't have in this whole formula? Just that.
F of x plus h.
That's the only thing you got to remember is your first step before you can start anything. You got to always find the purple one. So I've got this question. I'm like, well, that's great. I don't have this. So there it is. Now I have it. So therefore, f dash of x equals limit h approaches 0 of f of x plus h, which is this, minus root x plus 5. What? This is meant to cancel out, but you can't square root. What the? How do you get rid of this now? You can't split this up. You know you can't split it up to this. Don't start doing that. You know that's not allowed. You can't split up surds like that, because you can't add unlike surds. What the? So now you're stuck, because what I said, which is it's always got to cancel out, it's definitely not canceling out. Anyone have any idea, the more creative the better, of what you can do to get rid of the surds? And the first thing you thought of just now when I said that to get rid of the surds is the first one that everyone says. It's just not going to work for this one. But who wants to say it? How do I get rid of the surds now?
Square it.
Yeah, so that's the first one that everyone says. It's right for a different question. Because when you say square it, you're talking about sides. Square it on this side, true, and then square it on this side. Now look what you've just done. That's just messy. So won't work, but that's good try. And then there's a second version. How do I get rid of the square roots? A second way. Think of everything you've learned. Think of the topic.
Is there such thing as difference of two square roots?
You are kind of right, but you're not saying the right word. So I can't give that to you. But you're on the right track.
Do you factorize?
No, you can't factorize. Actually, you can't factorize because these are inside surds. So you're not allowed to split them up. Think of, see, you said factorize, right? That's part of the algebraic topic. Now think of just this topic, the surds topic. Think of everything you learnt in there. It'll come, believe me. The brain's
Do
very...
you put a half sign on them? How?
That won't help much, but I see what you're saying. That's part of more calculus stuff that we've been doing. Yep. Still getting closer, but
You put it to a fractional color?
yeah, that's what Eden just said, power of a half. You were very close when you said difference of two squares. It's just, I can't give that to you. Like, it will be a difference of two squares. I can't give it to you because you didn't say the right word for this topic. Think. Vinesh, any ideas?
I don't know.
No, any ideas? I don't know is not good. It's okay.
Completing the square.
Say it again.
Completing the square.
Completing the square won't work for this question. No, completing the square is more when you already have x squares, right? You've already got x squares and you want to make them into perfect squares. That's completing the square. So no, again, you guys are moving away from surds and into algebra. Just keep it in surds. Try again. Surds. Tell me okay. Eden, for example, we'll just pick you. Tell me everything you know in surds. Just give me stuff that you've done. Say a bunch of random words. Don't worry. Just go. Everything.
The square root is the power by a half.
Yep. Keep going.
It's would be on the inside, and then the bottom of the fraction for power would be on the outside.
In the surds topic, what else did you learn? Like you learned, I don't know, if you have a question like this, you look for perfect squares, and then that becomes 3 root 5, whatever. I don't know. You learn you can add surds that are only the same. You learn that you can multiply surds that are different. What else? If you guys keep doing this, you'll get the right answer. I just don't want to give it just yet. Come on.
You can add surds with the same power.
Add surds. Yep, that's correct. Keep going. What else did you do in surds? If you want, I'll give you the first letter, which probably will give the answer out.
Did you subtract the surds?
Nope, you can't. You can only subtract surds that are the same.
Rationalize.
Rationalize.
Oh, I can guess.
Didn't you guys do rationalizing in surds? That's a way to get rid of surds. The problem is you guys got taught only to rationalize where?
At the bottom.
When there was a
At the bottom, at the bottom, at the bottom, at the bottom. But there's no such thing. Rationalizing is not at the bottom. It's rationalizing either the top or the bottom so that you can get rid of the surds wherever they are. So here you've got surds on the top. You rationalize the top. Plus x plus 5. And that's plus x plus 5. So there's your difference of two squares, which is I think what you said. You do get a difference of two squares for rationalizing, if you guys remember that. But the whole point is, the reason why I say no one gets this right usually is because you guys are not taught to rationalize numerators, you're only taught to rationalize denominators. So for those students who get this right, they've been exposed to it. So now you guys, you've been exposed to it. I hope that if you get it in your exam, you're one of the few that can actually get it right. So your next line, look what happens. This times this is obviously just x plus h plus 5, no more surds, minus x plus 5 times x that, so that just becomes minus x plus 5 over the bottom. You're still going to have h, and you'll still have surds now in the bottom, which is not a problem, because at least I got rid of the problem that I had on the top, which is I got to get rid of this x plus 5 business. Minus x minus 5, gone. What do you have left at the top? Just the h, and obviously everything after this is really easy. But do we get what I've done there now with the rationalizing? Anyone have any issues with y plus instead of minus? I don't know if that's a question. That gives you 1, and then that equals to the limit. H approaches 0, 1 over this, sub in h equals 0. H equals 0, therefore you'll get 1 over root x plus 5 plus root x plus 5. See, even these are the same, you can only add like surds. So root x plus 5 plus root x plus 5 is 2 root x plus 5s. And that's it. That's the answer. And that's how that's the only way you can do it. So that's why I said put it in your books. Because there's not many kids that will be able to get this out if they've never done it before. In fact, there's nobody that could get it out if you haven't done rationalizing the numerator before, because you'll never think about it. But now you know. There's two ways of getting rid of surds, Lissandro. Way one is square it. But when you're saying square it, you're doing it to sides. Way two is rationalize, because then that way you're only doing it to the same side. You don't have to balance it to the other left-hand side. Make sense? And then cancel, sub in h equals 0, and then you're good. So that's a good one that I think you should keep in your books, in your wall, whatever you've got to do. Any questions? No? All right, that's that one done, and we are up to trig. So mainly the basic ones are the ones you want to know. If this one's asked, it's more asked because of the extension 1 kids. So it's to actually make sure they get challenged a little bit as well. Okay, that's that. Gone. Trig graphs. All right, let's do this. Last one. Trig graphs. Sine, cosine, tangent. 11. So will that type of question be in the prelim? Yeah, it can be. 11 revision. See? We've done what? We've done 2 revision papers so far, and we haven't seen that. So it's not like it will be, it's more that if it is, so they usually ask these ones, right, in prelims. But if it's this one, very unlikely for you to be able to get it right without having obviously done it before. But if it's not in your prelim, it could come up in your half yearlies in Year 12. It could come up in your trials in Year 12. It could come up in the HSC in Year 12. So you will see it, is what I'm trying to say. I don't know when you'll see it. I don't know if you'll see it this year or next year. You will see it in one of your papers. Your schools will put one of these in there, definitely. Because it's one that, Yeah, you either have done it before and know what you're doing, or you've never done it before and you're just going to get stuck from the beginning. That's it. You can't really move on past this line. Trig graphs. There's good news and there's bad news, Eden. What do you want? What do you want first? Sorry?
Bad news.
Bad news. Bad news is you don't know. Oh, sorry. Bad news is, yeah, you won't know what kind of graph it is, but bad news is you have to memorize the different graphs
Okay.
and their properties. That's it. That's
Oh
not
my
so,
gosh.
that's not so bad, is it?
No, not
news.
too bad.
Is that it's always the same
Yeah.
concept. So really, it's pretty much the same concept every single question. It's just if you will not be able to get it right if you haven't actually memorized the graph and its property. So let's do the first one. Sine graphs. Sine graphs look like this. They start from 0, they go up, they go down, and that's one sine graph up to 2 pi or 360 degrees. The middle is pi or 180 degrees. That's 0. This is 1. This is minus 1. The properties are amplitude, and that equals to 1. That's how high and low it goes. Your
Yep.
period is equal to 2 pi on n, where n is the number in front of x. So this graph here that we've drawn is y equals sine x. Your amplitude is the number in front of your sine.
Yeah.
Your period tells you how many sines you will wait, hold on. So if I say 2 pi on 3, how many, no, sorry, how often sine occurs? How, let's say that. That's probably going to be a bit easier. How often sine occurs? Occurs, is it double R? Double, no, single R. Right? Is it one C? Ugh, occurs. Why does that look weird?
You read it right.
Is it? Wow.
2 C's and 1 R.
Wow, it just looks so weird. Okay, how often sine occurs? All right. Yeah. Okay, so if I said, in this case, n is 1, right? The number in front of x is 1. So therefore, your period for this question is 2 pi. That means every 2 pi, you'll see one sine. There it is, one sine. If I had to go again, that would be 4 pi. If I had to go again, 6 pi, and so on. If I had to go backwards, that'll be negative 2 pi. So that tells me how often your function occurs. Amplitude's the number in front, and that's it. Eden, what do you reckon?
It's alright.
Right. I should be like, yeah, that makes so much sense.
Are they all different?
Well, no, the good news is if you know that for that one, all the other ones you just got to memorize are just the graphs. But the conclusion is the same. How often cosine occurs, how often tan occurs, or whatever. But that's one sine.
Wait, the period is the same for all of them.
Sorry?
The period is the same for cos and tan.
Just for cos. For tan, it's pi on n. So y equals
Okay.
cos x is this. Really bad, but pretty sure we get the idea. That's 2 pi. That's pi. 1 minus 1 because your amplitude is 1. Your period is still 2 pi on n, which is 1, which is 2 pi. Your amplitude is equal to 1. Any questions?
Mm,
So you got to memorize that graph. I can't do anything
yep.
if this graph isn't memorized. Just like your parabolas and your absolute value. You know, Tiana made you memorize all those graphs before. Same thing. It's just you've got to memorize these graphs. You can't do anything without them being memorized. Last one is y equals tan x. Tan has no amplitude because it goes on forever. You'll see that in a second. But your period is not every 2 pi. It's actually every pi on n. So for tan x, it's just pi. But your n is still your number in front of your x. So your period is pi. 1 tan looks like this. Has an asymptote at 90 degrees, because if you want to check it out. Oh, do we know that pi equals 180? You guys still remember that?
Yeah.
If you did tan 90, this gives you math error. And then there it is. That's 1 pi. Looks like that, which is weird. If you had to continue this, it'll look like this. So you continue this pattern, right? So that, asymptote, and voila. Then you continue it. Asymptote, voila. Good, 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 good. Okay. Any questions for me at this stage? So this means, again, every pi, your tan occurs. So if you get a period of 2 pi, that means every 2 pi, 1 tan occurs. Or whatever. Talk to me, Eden.
Yep, makes sense.
So y equals sine x, that's 1 sine graph. You've got to memorize it. 1 cos graph and 1 tan graph. So if I ask you guys now to go ahead and draw, that might look scary, but it's actually, and you got to draw it from 0 to 2 pi. It looks scary, but this is how I interpret it. Amplitude equals 3.
Yep.
Period equals 2 pi on 2, which equals to pi. So I know my sine, I see one sine every
Hello?
pi. It's the way you interpret this. One sine every pi. What's one sine look like? I draw myself one here. If I forget, there it is. That's one sine. Up, down. Okay, so here we go. Ready? There's your axis. You're going from 0 to 2 pi. So go up, go down, go up. That's one sine every pi. So that's pi only. Then I'm going to go again because I've got to stop at 2 pi. Go up, go down, go up. That's 2 pi. What's my amplitude? And
3 and -2.
And that's it. And if you had to, this one is pi on 2 because half of this. And you guys get the idea. Any questions? What if I didn't have it here? 0 to 2 pi? Please don't change your method. Do it the way I'm showing it to you. And if the question said draw it from 0 to pi, that's great. You would have drawn all of this. Then you just stop your graph there. Stop it at pi. If it said go from negative pi to pi, you just continue your graph. There's negative pi and so on. And if it said negative pi to pi, you're just going to draw this. Or if you've drawn the whole thing, you do exactly what I'm doing right now. You'll just highlight the bit they want to mark and just write mark highlighted section. Full marks.
You can do that.
Of course. Come on, but you can't, you know you can. You know, as long as you, if I've drawn it like this, can I do that? If I've drawn it like this, am I allowed to? No. If I've said mark highlighted only, what does that mean? Only mark the highlighted answer. So the other bit's just part of my working out. So leave it. I'm not getting any marks for that. That's my working out. Does that make sense? And yes, that is how we do it. I should have left that, just so you guys can remember that. Highlighted only. Done. Or you can write answer only. I don't know, whatever you want. as long as you don't just leave it with it and then highlight it and expect your teacher to know what you meant. So we don't know that. Okay, easy, 3 sign to it. Do you want to give me one, Eden, that you've done in class or that you've been doing in class or something to show it the way we've been doing it and see if you're comfortable with that as well?
Could we do like 4, 10, 2x?
Say it again. 4, 10,
4, 10, 2x.
4, 10, 2x. All right, let's do that. Y equals 4. The 4 doesn't do nothing, right? Because I told you 10 doesn't have amplitude.
Yes.
Yes, there it is.
Okay.
There it is. That's 110, isn't it?
Yep.
110 occurs every pi here. Okay, good. So my period is pi on what? 2. So that means 110 every.
90.
So instead of drawing it like this, I'm going to draw exactly the same. And what am I going to write here?
Over 2.
Yeah, good. You know it the way I know it. But that's how I do it. I cheat. I'm like, okay, it's just the same thing, just put a pi over 2. So if I had to draw this, what's your limits? Because you need limits, like what's your domain range? Or your domain, sorry.
Negative 2 pi and 2 pi.
Say it again.
Negative 2 pi and
Ne-
pi.
Negative 2
Wait.
pi
Pi.
to pi.
Yep.
Right? That. Yeah.
Oh,
So,
okay.
yeah, it doesn't matter. Look, even if it's something else, it doesn't matter. I'll do it all the way from negative 2 pi to 2 pi. And then I'll just show you guys how to stop it at pi. Because it's better to learn it like that. So, let's do this. So now you know you've got to go all the way up to pi. So let's start with that. And you've got to see 110 every pi on 2. So here we go. There's 110. So that's pi on 2. And then I go again. And I stop it at pi.
Pi.
And if you wanted to continue, you get, I think you guys get that. All right. I'm going to go to the left bit. Left. Where's the asymptote at? Negative pi on 4 technically, isn't it? Because half of pi on 2 is 45. So anyways, negative pi on 4 and then go again. Starts up here. Look at the pattern. Don't start it down here or be confused. Up here. There it is. There's your 1 on this side. Negative pi on 2. I'm going to definitely run out of room. Continue. That's a really bad graph for Sam. That's better. Negative pi over 2 and then asymptote. And then again. Yeah, I ran out of room. I was worried about that. That's okay. Negative pi over 2. Where was I? Pi over 2 is there, so do it again. 1. So just so you know, this was 1, right? 110 on the left side. You agree with that? 1 more 10 on the left side. Is that? Do you agree, Eden?
Yep.
And that's negative pi. Technically, I've got to do that 2 more times. So draw the yellow and the purple 2 more times on the left. And that would be the whole answer, from negative 2 pi to pi. It's not that it's hard, it's just a bit annoying. You've got to keep going. No, I've stuffed it up. I started too much on the in the middle. Do you get that?
Yep.
Tiana, Lissandro, how do you guys feel? That's all right. Tiana, what do you think? let's do another one. Oh, that's another one. Let's go. Y equals cos 4x. Okay, what's my amplitude? What's my
5.
period? Amplitude 5. Period. 2 pi on?
5/2.
No, 2 pi. Yeah, pi over 2. 2 pi over 4, pi over 2. So 1 cos every pi over 2. How does a cos look like? There. You're going to have a whole lot of coses. We're going to go from negative pi to pi. That's my domain. So here we go. Let's draw this guy up. There's your axis. Every 90 degrees, I'll see a cos. So start up here. There's 1. There's 2. Because that's 90 degrees, pi on 2. And this one is pi. Then left-hand side. And again. That would have been negative pi on 2. And that would have been negative pi. Finished. The only thing I haven't written is my amplitude is 5 and minus 5. Done. Eden, what do you think? Perfect at it now?
It's much yes.
Yeah, much easier now. That's it. Don't make it harder than what I've just shown you. It's meant to be that simple. So go ahead and try to practice it at your own time. Do a few, like 3-4 questions, and then you'll be surprised. Like, they're meant to be that simple. Rewatch the video if you have to. Go over it again and again and again until you're like, I fully get this. Okay. I think I'm happy with that. I will